Right, welcome to this Battle of the Cloud Data Warehouses. It is a session that is only slides. I don't have time to cram in any demos into this, but hopefully we can get you introduced to the concepts and so on, so you can start playing about with it yourself. First of all, my name is Johan Ludvig Brattås. I'm a lead solution architect at Capgemini in Norway, and I'm just announced MVP, so I had to rush off and find the logo to put on the slides. You can find me on LinkedIn or on Twitter or reach out on the email. First of all, today I'll be talking a bit about what is a cloud data warehouse or a cloud data platform and set that into context of data warehouses and data lakes. Then we'll set the battleground, look at the different opponents, and have the outcome of the battle or an analysis of what makes the different areas and what they are. So the enterprise data warehouse has been around in one shape or another since 1988. It evolved over time, and most of you have been in touch with at least two of the three main approaches. So the dimensional approach or Kimball, the normalized approach or Inman, and the Data Vault. Data Vault right now is in 2.0. I haven't been using it much myself, but it does show some promises. The enterprise data warehouse is subject-oriented, so it evolves around the subjects within your operational systems. And that is very nice for decision orientation, or sorry, decision making. It is integrated, so it tries to integrate all the various sources that are in your enterprise and present them in a way that it is easy to align and compare. It is time variant, meaning that while an operational system, OLTP system, will always reflect the day-to-day operations, a data warehouse keeps track of all your historical data and normally also shows you changes to data over time. It is also non-volatile, so there are very few changes in the system. There are, of course, things like slowly changing dimensions and so forth, but normally you try to keep the data as it is, and I rather show the changes. And it is summarized, so it's always dealing at an aggregated level, even though you can drill down quite a bit. Enterprises data warehouses contain structured schema on write data. They are relational, and as mentioned, they store historical data that needs to be transformed and qualified. And you typically transform them before you store them into their final version, though they can go in stages. And typically your data warehouse is very good for business decisions and to see how your operations are running. But that business decision means that you have a high quality focus and making sure that your numbers are correct, which again means that you generally have a long development life cycle. So it's not, or it didn't used to be unusual to see at least 2 to 3 months delivery of a report, which means that most users had forgotten what they asked for when they got it. So enter the data lake. The data lakes gained footholds around 2011, and it tried to answer some of the pains that were in the enterprise data warehouse around that time, namely the 3 big V's of big data, so volume, variety, and velocity. As the volume of data increased and the variety of data types increased and the velocity of data coming in increased, the relational databases started struggling performance. You could, of course, throw a lot of new hardware on it or at it, but that cost a lot of money, and in the end, another way of trying to approach this was the data lake. And data lakes you typically find in 2 different shapes, and those are the raw data lakes, so you just land data as is, so it's as close to source as possible, or the business data lake, or in another name for that is the layer data lake. So you have your raw layer and you have a curated layer on top. The business data lake has some principles. First of all, you land all the information you can as is with no modification. So that is landing it into your raw layer. Then you encourage line of business to create point solutions. So you let your line of business connect either to your curated data, but preferably to your raw layer, and let them do the transformation on that. This means that you can let the line of business decide on the cost/performance of their problem, and they will take over, which leaves IT to concentrate on governance only on the critical points, and they can assist line of business in transformation and so on, but it's still within line of business to decide how they want it done and take ownership of it. The corporate view or the enterprise view, which is one of the main things about enterprise data warehouse, in the business data lake, it's just another line of business view. Even though it encompasses it all, it's still just the CXO or line of business view, so to speak. And the business data lake considers all information, even whether it's unstructured or structured, it is still information. And one has to remember that the data lake does not contain everything, and you shouldn't assume it does. And scale is driven by the demands of the business, so you can scale both down as well as up. And the data lake is in its basic forms is a repository for data, so either in forms of blobs or files, images, you name it. It is per default schema on read, so you don't force any changes onto the data as you land it. And you can actually have a database as part of your data lake, or you can have CSVs, XML, JSON, JPEGs, PNGs, and so on. And you store all data within your data lake. And again, back to the raw layer, no transformation, that will happen later on. There are, of course, various use cases on the different layers of the data lake. Same thing with what kind of business users are, or what kind of users are accessing the various layers. It is great for trends and ad hoc analysis. Typically, you want your data scientists and data engineers to access the raw layer, whereas you put access on the curated layer for your business analysts and the users. Because it's good for trends and ad hoc analysis, it means that you do not have to use a lot of time to qualify your data or spend time on transforming it, which again leads to short time to market development cycles. And the various layers also allows you to enable data science in another way than a data warehouse can, and it lets your users do a lot of self-service. One of the challenges of data lake is because you try to land as much as possible into it, you might end up with a data swamp, and there's so much data in it that neither you nor your users actually make sense of everything that is in there. Which is, I think it's a generic IT problem. You really want to take care of everything. It might be nice to have at some time, so just keep it. Oh, this network card, it has token ring, but sure, that might come in handy sometime. So enter the cloud data warehouse. That has been evolved over time. Initially, it was a response to the challenges faced by traditional relational database systems. And they implemented a massive parallel processing paradigm. For instance, you had the SQL active or analysis application, which is then turned into SQL Data Warehouse. But it is still a take on an enterprise data warehouse. So it's still relational, it still has qualifying data quality issues and so forth. The battleground, of course, we're talking about cloud data warehouses. The battleground is in the cloud. And the challenge is to see, can we merge enterprise data warehouse and data lake functionality somehow? And suggested for solving this issue has been suggested by many. One of these is Gartner's logical data warehouse. Another thing that has come up is virtualization with the likes of TIBCO and Denodo. And while virtualization seems very cool, there are still some issues in it, and it hasn't really taken on that much, which then is opening up for the new data warehouse solutions. And these are the opponents that you will find on this battleground. First of all, we have Azure with Azure Synapse. Then you have AWS with Redshift. You have Google with their BigQuery engine, and you have Snowflake. And in addition to this, Databricks is coming up as an outsider, but I'm not going to compare that in today's session, but I'll just mention it briefly later on to see, we'll talk a little bit about what it is. So Redshift is also, as I said, it's a massive parallel relational database system. It is based on PostgreSQL, but it is based on Postgres at the same thing that SQL Server is based on Sybase. It used to be the same, but it's not anymore. It is columnar in the way it approaches. So for those of you who are familiar with column store, that is a columnar technology. And it uses a distributed database system, so you have parallel databases and controller nodes. So you distribute your data across the databases within the cluster, with a controller node then having control of the query and sending the query off to the different databases within that cluster, and then returns the result and gathers it up afterwards. In AWS, you have some different distribution types, again, partitioning of the data over the databases. One of them is distribution by key. You can do an all, which means that you dump all data into one database. Or you have an even, which is sort of a round robin, so you distribute evenly across without any specific partitioning key on it. And it has three different versions. You have your dense storage, which they call DS2. Then you have your dense compute, which is DC2. And then you have what they call AQUA, Advanced Query Accelerator, or RA3. And these three versions are generally available, though advanced. So RA3 was announced in January, I think it was. So the architecture of the DS and DC2 versions, they are very similar in architecture. It is only the amount of, or the focus, if it's on the storage or on compute. So the DS has slower storage and it has slower compute. DC2 has SSD disks and more compute nodes into it. But both of them have a leader node, and then you have compute nodes. And a compute node consists of slices and storage combined. So you do not have a separate storage and compute layer. Everything is combined into one single node, which means that if you pause it, the data will be unavailable, or the data will be then just stopped. So you can't really pause it in the same way you can Synapse or Snowflake, for instance. The RA3 version is slightly different. It tries to do the same thing with the leader node, but it has compute nodes separate, and then you have managed storage, and the storage is SSDs and S3. So you have your hot store, which is your SSD disks, and then they offload data into S3 buckets as a cheaper managed storage area for data that is deemed as cold. In addition to that, Redshift has a service called Redshift Spectrum. And Redshift Spectrum is the solution for the second part of the Cloud Data Warehouse challenge, how to integrate your enterprise data warehouse with a massive parallel compute with the data lake. So in Redshift Spectrum, you can query your data lake or your S3 buckets using SQL and external tables. And then you can pull that data in as materialized views, or you can use the external tables as staging tables and then dump data from there and transform it within Redshift. Next one up is Snowflake, and Snowflake is pure cloud data platform from their selling point of view. And it's not based, at least I'm not aware of it being based on any specific database distribution underneath. I think it's built from the ground up. But it is ANSI SQL based. It is also a columnar database, but it has separate compute, which we call warehouses, and you have separate storage, but the storage is shared among the warehouses, unlike RA3, which you have compute and storage within one single node, so to speak. And it is sold as maintenance free, meaning that you do not need to have any DBAs tuning indexes, maintaining or defragging and so on. That is handled out of the box within Snowflake. Of course, you do need to think about things like partitioning and so forth anyways, but from a marketing point of view, maintenance free sounds so much better. Snowflake architecture, as I mentioned, is separate virtual warehouse with a cache, so that's your compute resources. Then you have your single storage underneath, as well as you have your cloud services, so infrastructure manager, query optimizer, transaction manager, security. All metadata is stored in a separate repository, which is very handy when we are dealing with different compute nodes, as well as it lets Snowflake handle different data varieties or data types in a different way than a lot of the other data warehouses. I mentioned those. And it also has connectors to all the main clouds. You can run Snowflake both on Azure, AWS, and Google. One of the good things about Snowflake is the way that you have your separate compute nodes, which means that you can have a dedicated warehouse per use case. So you have one warehouse or compute node for ETL. You have another one for finance, one for dev and test environments. You have one for your dashboards, one for marketing, and so forth. Those data warehouses or the warehouses are auto-scalable. You can scale them up and down as needed. You tune that yourself, so that's not really maintenance free, but an admin can dedicate how much it can scale up and then down again. You also have an auto pause option, which means that if you're dedicating your warehouses per use case, so finance is one, and you know that finance goes to lunch as a department at 11, which is a very Norwegian thing to do. Believe me, we stress out of the office at 11 o'clock queue in the cafeteria, in normal circumstances at least. And then you have marketing, which is placed in Sweden, where they go to lunch at 12:30 or something. That means that they can set the SQL warehouse or the warehouse for finance to stop at 11 and then open up again or start up again whenever somebody comes back from lunch and starts querying, or at a certain interval afterwards, say 30 minutes afterwards, you start it up again. And then the marketing department's warehouse pauses at 12:30 or 10 minutes after somebody stopped using it, because marketing only do check on their reports whenever they have a campaign running. So they just need it. I think the warm-up period after it has been paused is something like 2 to 3 minutes. So it's quite survivable for somebody to wait that amount of time before they get the results back. They also have a very quick data cloning for dev and test environments. So you can, of course, you shouldn't develop on your production databases, but you quickly take a clone of your production data, and it's ready for you to use within a couple of minutes. Snowflake also lets you query over data lakes using file shares, and you connect these file shares to the corresponding data lake within that cloud you run on, whether that be Azure storage or S3 buckets or big tables or what have you in Google. And then you pull that data in as external tables, and again you can build materialized views on top of it. The way that Snowflake also does this is that you can start building pipelines, what they call Snowpipe, to ingest data from the external data lakes on a trigger-based functionality. So why is Snowflake a cloud data platform? It is quite a lot of marketing, of course, but the width of the functionality that you can get out of the box within Snowflake is, of course, one thing is that you have all the different sources it's applied. You can throw JSON, XML, what have you on it, and it will just ingest it without any problem and have it ready for querying within milliseconds. As we talked about, data warehouses and data lakes, you have your data engineering in your Snowpipes. There is an ability within Snowflake to do data sharing, either to your customers or to your third-party partners. There is also the data exchange within the Snowflake marketplace, so you can monetize your data if you want. And then you can build data applications and do data science and so forth on top of that. So Snowflake has quite a broad scope, which makes it interesting. But I don't agree that it is a full cloud data platform. I'll mention that a bit later. So Azure Synapse Analytics, or the service formerly known as SQL Data Warehouse. And the SQL Data Warehouse part of it is a SQL server in a massive parallel processing way. And of course, you use your regular T-SQL to query it, though there are some T-SQL functionalities that are exclusive to Synapse Analytics, which you don't find in SQL Server. It is columnar per default, but you do have the option of turning off column store and on the table and use row-based indexes instead. Your use case might vary on that, but from a compressed data compression point of view, at least, columnar wins hands down. And Synapse Analytics also runs separate compute and storage, but it is a distributed database system, meaning that you have the same clusters with a controller node. For those of you who might try it out SQL Data Warehouse, if you start it up in the portal, and then you can open up your Management Studio, you will see your Synapse or SQL Data Warehouse database as a regular SQL database. But what you're talking to is the controller node. The data is not stored there, it's stored within these, I think they are running 6 parallel databases within each node in the cluster. And as a default, I think it's three nodes within that cluster, so that's 18 databases. And SQL Data Warehouse also have a variety of distribution types on how you want to distribute your data. You can do it by partition key, such as year or something else. You can do everything into one single database. Typically that is as a staging table, or if you're using dimensional tables, that also applies to Redshift, of course. Dimensional tables, you want to distribute that in every single database should have a copy of the dimensional tables. And in addition to partition key, you have round robin, which again is what we talked about as even, or called even, on Redshift. So Azure Synapse, which just went into general availability, is trying to answer the same thing that RI3 does and that Snowflake does in talking to a variety of different data sources, both relational and your data lake store. Typically, before Synapse came in, you had to use Data Factory to ingest, then use Databricks or similar to transform the data and dump that into your data lake store or directly into your SQL Data Warehouse, and then that will be available for querying. Synapse Analytics tries to pull that full breadth of ingestion, transformation, and data warehousing into one single package, which is basically what you see as the Azure Synapse Studio. And then talk on top of Azure Data Lake Store. And the external table technology, you might know that from before, it's called Polybase. And with Polybase 2.0, which was released recently, it has way larger scope than the Polybase 1, which was just basically querying against HDFS stores. You now also can query across a whole variety of relational databases and other connectors as well. As I mentioned, Azure Synapse is more than just your massive parallel relational database. It also has serverless SQL pools, which is perfect for doing ad hoc query on files in your data lake. It has the Polybase 2.0, as I mentioned, for queries on external data sources. It has Azure Spark for big in-memory processing of data. And it contains Azure Data Factory pipelines, both data flows and pipelines, by the way. And you have a Power BI connector. And all of that is within one single workspace. So it's a lot easier to work with. You can sit across the whole breadth of the platform and work. Only annoyance is that Power BI right now, if you're going to work on it from Synapse, you first have to download or create a connection in your Power BI desktop and publish that as a data set before you can work on it within Synapse. Hopefully that will be fixed soon. And also last week they added source control to the Synapse workspace, and these days you also get in public preview codeless machine learning or data science tools. Next up is Google BigQuery, and Google BigQuery is serverless, which means that it doesn't really care about things like number of nodes and controllers and so on. It scales to whatever needs to be thrown at it to deliver that query you sent into it. It is also ANSI SQL based, so it's another very easy to get up and running both on Snowflake and BigQuery, as long as you're familiar with the SQL Server or PL/SQL. And it also does separate compute and storage, but again, since it's serverless, it doesn't really matter how you see it. And it is columnar format. And you can see the architecture on it with the root server, which is what you're talking to, and then it scales out when it decides on execution. It just scales out the number of leaf servers that is needed to reply within the given SLA it has. Thing is, because it's serverless, you do not pay for the capacity you reserve, you pay per query. And you also pay for the storage a bit, as well as if you're streaming data in, you have a subcharge for each streaming data that comes in as well. Google BigQuery is optimized for wide tables. And the reason why I'm saying it this way is because normally when we're dealing with data warehouses, we are building star schemas or Snowflake schemas. And to do that, you need joins. And for those of you who are familiar with looking at the query planning, joins lead to throughput of data. So the more joins you have, the more data you're pushing through until you're getting your end result back. And since you're paying per query and the query is priced per amount of data that is pushed through the whole query from storage until the result. So you want as wide tables with as few joins as possible. And as I mentioned, it supports both streaming data as well as batch out of the box. Another new thing which is quite cool about Google BigQuery is BigQuery Omni. It was released in September, I think, which allows you, by enabling Anthos, which is their version of Arc, enables you to run BigQuery in Azure or AWS, supported by Anthos. So you run your queries on where your data is. So if your data is in an S3 bucket, you can deploy BigQuery through Anthos and query it there instead, which is opening up for a whole new fun way of doing multi-cloud functionality. I haven't been able to try it myself yet, but I'm really looking forward to giving it a spin because it's opened up a lot of different possibilities. Special mention, as I said in the beginning, Databricks Delta Lake. Databricks has really come up as a full-fledged cloud data platform or cloud data warehouse solution. Shortly after I made this presentation, they had their summit and they launched new SQL functionality, which means that you get even more functionality out of the box by using Delta Lake transformation with ingestion tables, refined tables, and so on into your lake house, which is a horrible marketing term, but there you go, on top of your existing data lake. So it is definitely something to watch, and they take on a whole lot of new functionality that is definitely something you should look into if you're working with Databricks as of now. So I've mentioned all these different services. Now let's have a look at how they compare. So all the different components superficially resemble each other. They use some sort of a SQL dialect to query it. And yes, it's easy to start using them. All of them allows you to query against external data, so they merge the data lake and the data warehouse. And one of the advantages of this is, of course, that it opens up to combine the raw layer of your data lake as the staging table or operational data store for your data warehouse, and then the operational data warehouse, enterprise data warehouse, can then build their data marts and so forth going onwards, as well as then both the raw layer and a curated layer on top for data lake can be used for ad hoc analysis either within this database system or just lets data scientists connect with Python or Databricks or something else. But only Synapse offers connections to other relational database systems as part of the package. So Synapse offers, in addition to data lakes, SQL Server, MySQL, Teradata, Oracle, and a few others, which gives it a whole new option or a whole new functionality of the virtualization technology. So you can actually start to replace some of what you have with Denodo or TIBCO using Synapse. BigQuery also has a connector to Cloud SQL, whereas Snowflake and Redshift only have queries against the data lake. And Redshift Spectrum also is priced per query, so that gives another complexity to the pricing model. And all components are scalable, and they're talking about petabyte size scaling, and depending on who you talk to, none of the others can do that, or at least not as well. However, Redshift only offers 2 different scales per version. So you have small and large. That's it. There's nothing in between. And it also makes it a lot harder to scale up and down. You generally end up on the tier that you want to use, and that's where you will be staying. Of course, then you can scale from DS2 to DC2 and then to RI3 if you want, but it's still not scalable in the same way. And BigQuery in this setting is serverless, so it's scale isn't really something that you need to think about when you're using BigQuery. For loading data into your cloud data warehouse, all of them support external ETL tools, be that Matillion, Fivetran, Talend, Informatica, you name it, they are supported. And of course, all these tools say, oh, but we are the only ones being native connectors to this technology. Redshift and Synapse SQL pools need to do design decisions on distribution, so you need to think a lot more into database design, unlike Snowflake and BigQuery, where everything is just dumped into the database. Yes, you need to think about in Snowflake how to partition your data, but that's it. And in BigQuery, you need to design to avoid joins, again, since you're paid for them per query on the amount of data that's pushed through that query. That is a design decision. And Snowflake does not have these constraints outside of, yes, you need to think about, or you should think about partitioning, but that's it. To query against the data in your databases or in the systems, all the servers offer browser-based query tools, and all of them offer APIs. And of course, there are third-party tools that use these tools, APIs as well. But Synapse has by far the richest workplace for full development end-to-end. Snowflake has just launched into beta a new version of their query tool. It's still a bit simpler than Synapse, but it is at least a step above what they have in production right now. One important factor is which version is the fastest. And if you Google, you will find every vendor has research institutes supporting them that they are the fastest. I have been asked to do, when the last time I did this, I had a question of why can't you just show us a query and show us which wins? But it really, really depends, because the way that you design your database, the way you design your distribution, are you doing star schema or are you not doing star schema? What size of your data is there? Do you want scaling and so forth? So it really, really depends on the use case and what kind of data that you have. And Fivetran, which was this third-party ETL tool, or sorry, they are an ELT tool, did a query or a test recently where they found that the differences between these 4 main competitors is minimal in terms of speed. It depends again on how you design your query. So I'm not going to do a demo on that. It doesn't really matter in the context. It's the full scope that is what is important here. Availability-wise, Synapse was released on Thursday worldwide, though it's probably not available in all regions with a full extent just yet. But at least in most regions it's now available with the full extent of services, so both Data Factory and Spark clusters and SQL pools and everything. Snowflake is available worldwide, but for instance, if you're like me, most of your customers are in the Nordics. There are no Snowflake data centers available in the Nordics. You have to go to either Western Europe, which is Amsterdam, or Switzerland if you're on Azure, or you can go to London or Ireland, I think, if it's AWS and Google. So there are a few data centers per region, and they're basically connected to the main hubs where all the 3 cloud providers rent data center space within the same pole, or same center. Redshift is also available worldwide, but the latest and greatest version, RA3, is only available in a few data centers within each region. So I think it's Western Europe, parts of the US, and a few other places. BigQuery is available worldwide within each of the data centers that are in the Google Cloud. Next up, pricing. Redshift has a varying price per version and then per tier, as well as having a separate pricing for Spectrum. And then you have to also think about how to partition your data on your hot and cold storage. So you have in RA3, so you have your SSDs and caches in near the compute nodes, and then you have colder storage in the cheaper storage area. So there are a lot of variables, even though they, since there are so few, you only have 2 options per tier, you're locked in some way. Snowflake prices storage per gigabytes and then compute per second, and node size at compute time, and the data that is pushed through. Synapse is auto-scalable up and down on the SQL Data Warehouse. Serverless, of course, means that it's just spun up when you're using it. You can tune your Spark cluster selection as well, and they also auto-pause. Both SQL Data Warehouse and the Spark clusters auto-pause. And of course, when you're doing Spark clusters, you can decide on how large it is. So it's quite flexible and quite scalable. Okay, I was saying, I mixed up Snowflake's prices per storage per gigabyte and compute per second. I'll just skip back. Snowflake prices storage per gigabyte and compute per second. And that means that when you enable auto pause, it will stop billing. So yeah, I think they price it per second, but they tend to bill per minute. And it's priced according to the node size at the compute time. So it means that even though you start off with an extra small, and then you scale up to extra large for the high volume time in the day, and then you scale down again to extra small during nighttime, and then pause it, you will pay for the size that it is at the second of compute time. So even though it comes across as very expensive in a lot of research options, if you tune it correctly and you are eager on your auto pausing and so on, it isn't actually as costly as it might seem. BigQuery, again, prices for storage as well as streaming inserts and per megabyte passed through the query. I had in a session I had at Past Summit last year, one of the attendees mentioned that an analyst at her company had been boasting about just having run a $50,000 query. I haven't been trying that myself, luckily, but and it had been approved. But it means that it's personally the pricing of BigQuery scares me a bit. It seems to be quite volatile, but it's probably just me having not used it as much as I should form a proper opinion on it. So why aren't they real data platforms? Well, in my opinion, a real data platform, apart from doing an end-to-end ingestion of data, storing it in the raw data lake, transforming data to curated data lake / inserting it into a data warehouse, and then offering some sort of reporting on top or not, depending on whether you want. It is lacking in the data governance and trust domains. So data governance, so lineage, data quality, data catalog. So how to let your users know what data is in there and how to trust it. AWS has a catalog if you're using the native Glue service for ETL. Otherwise, no. Azure Data Catalog version 1 is there, but it's not very good at all. And none of them have, as I said, proper lineage data quality and governance tools, though of course there are lots of third-party tools out there that you can use, things like Informatica or Relation and so forth. However, Azure last week, when Synapse went GA, they also launched Purview, which was previously known as Data Catalog version 2. It has been in private beta or private preview since December last year, and it has been delayed and delayed and delayed. And one of the reasons is that they changed or they added a lot more functionality in terms of lineage and data quality and governance outside of the data catalog. So it's still in preview, and it has the potential to be a game changer, but of course we'll have to wait and see until it's been production tested for a while to see if it really delivers what it promises. So the verdict, from my point of view, Azure Synapse is the winner. And the reason why it's the winner is because it offers a full scope or full breadth cooperation workspace with all the functionality that you need for a cloud data warehouse underneath. The Purview edition is promising as well, but still it's the end-to-end offering within Synapse that marks it as a winner, though Snowflake comes in a very, very close second. And it really comes up to your use case whether I would say go Snowflake or go Synapse, because Snowflake is bloody fast, if you pardon my French. I've thrown XML at it, JSON at it, and it's available and queryable without you really realizing what you've done. And because it's scalable, it is really flexible as well. Of course, it is a premium cost to it, but if you, as I had mentioned on the pricing, if you tune it properly and set it up properly, it's easy to take control of or ownership of your costs. AWS Redshift is getting there. RI3 with Spectrum sounds or looks very promising. I'm not too fond of the pricing model or the scale model on it, but at least now that you have separate compute and storage means that it's easier to scale it and pause it and get more control over those things, I hope. And BigQuery is not exactly a loser either, because for certain use cases, for instance, if you are doing data warehousing with huge tables or wide tables, BigQuery might be the best fit for you. And it is also really fast, and because it is serverless, you don't really need to think about scale. But again, you need to keep watch of your pricing. So one thing I forgot to mention about BigQuery pricing is that BigQuery, if there's a query that has been run before, it is in the cache, and then and cache queries are free or included, whatever you call it. All right, that about sums up my session. Do we have any questions?
Cool. Yeah, we've got some questions.
Lohith asked the first question, but what is schema on write?
Yeah, so schema on read versus schema on write. Schema on write is when you take your data and you say, this is a column with integer, this is a column with varchar 10, this is a column with big int, and so forth. So you force the data into a schema that you already know. That is a traditional database table, is a schema that you write data into.
And the opposite is schema on read, where you defined in the query, you define what metadata you get back, right?
Yeah, exactly.
Yeah.
Given that Data Warehouse lends itself to waterfall-based delivery, whereas using Data Lakehouse enables a more agile, iterative approach, don't you think that the risk is that you'll end up with a very disjointed BI solution?
No, and again, I disagree that well, yes, it might lend itself to a waterfall approach, but you can still do DevOps on a database, on a BI solution. But the thing is, you need to look at the different needs of your users. Data warehousing is typically your business decisions, business support, so CXO dashboards or financial reports, whereas the data lake, and even though if you pull the data lake into being queryable from a SQL point of view, it's still from trending and ad hoc analysis, and they are separate codes objects but they can both still be aligned in the same strategy and the same technology. So I disagree that it is a waterfall approach on data warehousing. You can do DevOps on everything. The main thing I think is to be successful on BI solutioning DevOps, you need to write your tasks and your user stories in a way that you can create your tests out of them before you start developing your code. And there are now, in addition to CSQL, there is also another BI, I think it's nbi.io, NBI framework for testing BI specific solutions, which is really cool.
And next question was the business data lake principle. Does it increase the risk of duplicating work between departments and having inconsistent analysis?
It increases the risk of inconsistent analysis, yes, because doing self-service or opening up for self-service, opening up a can of worms that is called several different versions of the truth. So you need to have a strategy towards that, and that includes metadata management as well as some sort of a governance on the truths you find. But it comes back to your strategy for implementing a data lake and how you approach it, really, and make sure that you only give access to the raw layer for data scientist purposes and for data engineers. And at least when you push data into the curated data lake, you have some sort of a data catalog or metadata repository that lets self-service test what they can find and how they can. That also includes the business glossary, of course. So we know that in this company we define sales metrics as such, or year-over-year sales is this definition, because that increases the quality of versions of the truth.
So, isn't data virtualization really just a fantasy, since there will always end up being data movement and multiple copies of source data in any solution?
Yes, actually it is. Data virtualization itself, personally, I'm no fan of it, because when you see Denodo and Tibco selling themselves in, it's so easy. But for one thing, it's hard to find competency among people, and it's always as slow as the slowest source. So if you're querying data across Spark, SQL Server, Sybase, and files, the speed of the query will be the speed of the files. So it doesn't matter what hard iron you have behind it. So therefore, you always end up caching, and you pull data into the cache. But doing a virtualization or a logical data warehouse within Snowflake or one of the data warehouses offers you the ability to have data that is qualified and curated and ETL'd into your data warehouse, and combine that with the data that is not qualified and structured and more for ad hoc analysis into the same layer. And you can then either decide to pull that data in and do a materialized view on it, or leave it there and have a slower or higher latency on the query. And that gives you as BI department or the ETL developers very easy tools to deliver something straight out to the market without having going to do 2 months testing in SSIS, for instance.
Bit of a silly one from me here, which you have come to expect. So I've seen in a diagram that describes a Snowflake pod, and I wondered whether the Snowflake solution is managed or handled by Kubernetes behind the scenes.
I don't know. Most likely there are some container-biased technology on the backside here. They won't tell me.
Okay.
But do you run Snowflake in the same Azure, AWS, Google data center as your data, or is the Snowflake solution hosted by Snowflake,
It is
considering egress cost for data?
Yeah, no, it is hosted by Snowflake, but they have agreements with the different cloud centers, so it is considered. It is not considered as egress data.
Okay, thanks. Good.
Yeah. But as I mentioned, most of you might know this, that a lot of areas, Azure or Microsoft and Amazon don't own their own data centers. They rent space at huge data centers. So you can have both Google, Amazon, and Azure within the same data center, just different racks. and that is where you find Snowflake as well. And then they just pull patches or hard cabled between the different centers. So there is very little latency, and there is not a lot of data movement going on that way.
So I think you touched on some of the reasons here, but what functionality would be the main reason in your eyes that would go for Synapse Analytics over Azure Databricks?
Well, Azure's or Databricks is right now purely in memory, so you can't persist the data, even though I haven't tested the new data SQL query functionality. That might have changed. So persisting your data within Databricks is very, very expensive. And then you will have to still run queries to get the results back. You can, of course, push it out to a SQL file, a CSV file, and read it from there. But Synapse Analytics is an end-to-end solution. So you build your pipelines when you can use Spark or .NET or SQL or R to build your data pipelines and transformation. You can run the compute on Spark if you want, and then you can persist it into SQL or to Parquet or whatever you want to persist it as afterwards. And if you persist it to SQL, SQL Data Warehouse comes with materialized views, which you don't find in regular SQL, and it also caches the queries. So when you then start doing BI reporting, you hit the cache and you get a lot better response on it. So it's again, it's the full breadth of the offering within Synapse that is the best selling point in my opinion.
I guess this one is a simple yes or no question. Does inserting or preparing data for Google BigQuery mean that you have to join everything together and have just one huge table of the truth to get optimal performance and price?
Not necessarily one big table, but yes, Google BigQuery lends itself to big tables. It does.
Yep.
I did this session at Past Summit this year, and I had one attendee who actually was looking into which data warehouse to choose, and they had everything they had in their regular SQL right now was wide tables. They had like 300 columns or something, and for them, BigQuery was really the best option.
So moving on to a question by Jan. What is the level of effort to move from on-premise data warehouse to cloud?
It depends. It's a cheap answer. It does depend on what do you want to do with your data warehouse. How much data is there in it? What kind of ETL solutions do you have? I mean, you can take your SSIS packages and your SQL data warehouse on-premise, move it to an Azure SQL DB, spin up an Azure Data Factory SSIS runtime, change the connection string in your SSIS packages, and deploy it, and Bob's your uncle. But most likely you will want to refactor in one way or another. And then again, it depends on your use case, your pain points, and so on. So I tend to recommend that you refactor, and then something between 5 months up to 2 years. Again, complexity depends on what kind of data warehouse you have.
Another price question. I think you scared us a lot there with a $50,000 query. Can any of the products have a price cap or some kind of governor where they refuse to reply if you spend over your set limit? Or more to the point, do you know the potential cost of a query before you run it? Can you get an estimate somehow?
Yes, you can. The guy with the $50,000 query had got it approved before he ran it. So yes, you can get an estimate. That is for BigQuery. Nice. The other ones do not have the same kind of cost estimate on them because they are not priced in the same way. But again, you can configure your setup in a way that it allows you at least to get a proper overview of what you need and what you need to pay for. And I know that Snowflake in that way is very tempting for a lot of people, companies where they have internal billing, because it's so much easier to show the exact cost for finance versus marketing versus front end when it comes to their data warehousing needs, because they have their separate compute nodes.
If you're currently running a OLAP solution in Azure SQL, you're using column store to store the data. in that solution. When do you know that now is the time to move across to Azure Synapse or Snowflake? What's the trigger for thinking, yeah, we need to go there?
I would say pain points in either the ETL process or pain points in performance might be the biggest triggers. If it's performance and speed, again, it depends a bit on your usage scenario, but for pure speed, I have yet to see anything that beats Snowflake. And column store, even though it's very nice for compression, it has some very, very, very specific use cases for it to be performant. I've seen the same query in using column store take 20 seconds, and with a proper or a wide all table row index take 4 seconds. I'm not a huge fan of column store for performance. It comes down to you need to have the specific aggregated analysis queries for it to perform well. So if speed is the only thing, then I would definitely look closer at Snowflake. If it's the whole package where ETL and performance generally, and you do a lot of analytic queries, Synapse definitely.
I can almost imagine Nico Neugebauer shouting at the screen. Are you saying that?
Yeah, well, I had an argument with Stein Winans on the exact thing because he had been going around talking about how fast column store was, and I no.
Excellent.
So we have managed to make enemies of Nico and Stein. So let's try also to make an enemy of Mr. BI himself, Kimball. Ian has a question about how relevant is dimensional modeling and star schema in the modern cloud data warehousing. So do we need him?
Yeah, we do need him, but again, it depends on your use case. If you're doing Redshift or Synapse, they are tailored towards star schema. You distribute your fact tables across the nodes and the copies of each database within each node, and you as per partition, and then you distribute your dimensional tables, a full copy of each dimensional table on each different copy of the database to get the speed you want. Whereas if you're doing Snowflake or BigQuery, nah, doesn't matter. I mean, Snowflake says they like star schema as well, but it really depends. If you're doing Power BI on top of it, Power BI loves star schema. So it depends on where you want to put it, but it's not going away quite soon.
That was an excellent answer to the last of our questions. Thanks. So I say thanks to everybody and bye from Sweden.
Bye from the UK.
And Norway. Bye.